Hello and good morning, everyone. Thank you for joining the first TwInsider session. I'm Laurent Dekany, Communication Coordinator of the TwinEU project. And what we try to start today is a session of webinars and online workshops under the umbrella of the TwinEU project. Because TwinEU is big, we have 75 partners. But we also have the objective to bring or develop a pan-European solution, a pan-European digital twin of the electricity system, which cannot be done only with the partners of the TwinEU project. So that's why, on one hand, we will of course give you some update on the project itself, but we also want to involve you in this process to find the pan-European solution for this digital twin. So what do we have in the box today is we split the session into two hubs. In the first one, we will concentrate more on the challenges of the adoption of digital twins in the electricity system, while in the second part, we will focus more on the opportunities that the digital twins can bring to the system and the system actors. So first of all, in the beginning, we will give you a little bit of a policy context, and then we will see how other projects and organizations are handling the issue of adopting the digital twins. So without further ado, I would give the floor to George Paunescu, who is the policy officer in DG ENER. So George, if you can take over the screen.
Yes, thank you, Laurent, and thanks TwinEU for inviting me today. I started to share the screen. I don't know if you can see it.
Yes, perfectly. Thank you.
Excellent. Good afternoon, everyone. Good morning, sorry. I'm getting a bit ahead of myself today. In the first few minutes, I thought I can give you an overview from the policy perspective. What was the main trigger behind many of the discussions we are having today? And the starting point was 2 years ago, more or less, when the EU Action Plan for Digitalizing the Energy System was published. This is the action plan with the link, and it consisted basically of 2 papers, one communication and one staff working document with a bit more technical content and explanations than the communication. The action plan, many of you might be well aware of, focuses on 6 areas of action, 6 pillars. We are looking both at the opportunities brought by digitalization, like opportunities to share data and improve the flows of data, promote investments, benefits for consumers, but also at the challenges brought by the cybersecurity and the increased energy consumption of the smart solutions. And we have a coordination component in the action plan. Well, from all these pillars of action, for the discussion today, I will focus on the one on investments in grids. And this contains basically 2 main actions. And the first is exactly on taking action to develop concepts and demonstrations on the digital twin of the electricity grids, where the front runners are the TSOs and DSOs, of course. And this received a lot of attention right from the beginning and a good feedback, good response. And in December 2022, when the action plan was launched, the ENTSO-E and the DSO entities signed the declaration of intent to cooperate and develop actions in line with the lines of the action plan. And they created a joint task force that's been working for some time, and it has an initial work plan to develop a blueprint for the adoption of digital twins. I will not enter into details here because you'll hear full details a bit later on. And then just to mention other two actions. One is exactly the project that's presented today, the TwinEU, the flagship project, and started in 2024, and a younger project that just started this year. It's focusing on support for DSOs to contribute to these activities and update make the best use of the solutions that are developed. And you'll hear both, again, full details a bit later. So that's the starting point, and I wanted to present you the full range of actions, work streams that are going on to understand better the landscape. And I wanted to bring up the other action in the action plan on digitalization because it has strong synergies, and it looks at developing common smart grid indicators, so indicators for investments in smart grids, for focusing investments and monitoring these investments. And here the pen holders, if in the first part where the grid operators, here are the regulators, and with a strong contribution from the grid operators. And a first working paper was presented last year at the annual European Energy Infrastructure Forum in Copenhagen. And this year, a more complete set of indicators will be presented in June 2025. So these are the two main actions looking at promoting investments in grids in the action plan. But going back to digital twins, what are the objectives of these actions? And I thought I could quote here a bit from the declaration of intent, because it's very sort of good self-explanatory, signed by the grid operators, by the TSOs and DSOs. And this looks at accelerating investments in smartness of the grids and more operational to develop digital twins to enhance the smartness. These are a key tool, and to deploy new capabilities in the grid operators, both at the infrastructure and functional levels. And there were identified from the outset 5 areas to look at, to develop. And these are observability and controllability, which are, you know better than me, are fundamental, and especially at the DSO level, they need to be very much reinforced. We are looking at the infrastructure planning with all the challenges that are brought by decentralization and decarbonization, at operations, of course, and having a resilient grid, having smart solutions, active system management to cope with the system transformation and flexibility, but also to ensure a closer cooperation between TSOs and DSOs and address the technical problems of data exchanges. And we have some very good objectives defined in the TwinEU project. I don't enter into details again here, just wanted to say that they look at both at the technical parts, the reference architectures, use cases, services, going down to deployment, ensuring a large adoption, and creating conditions for longer term developments. And finally, what was the thinking when the Commission put forward this the action plan and the idea of developing digital twins? So basically the main ideas we had in mind, the main drivers were to create a common vision, to create a critical mass of like-minded people, organizations, and to align views on a raft of technical matters, which we understand they are quite different on use cases, reference architectures, what are the system services, and looking at fine things like data interoperability. And in all this, to consolidate communities of practice and to facilitate knowledge sharing. So to have, again, critical organizations, masses of people, not only front runners and let's say organizations that are not doing much. And in these to advance the innovation and work together on problem solving. And ultimately, these are considered to alleviate the implementation risks. So all the organizations are seeing what are the benefits, are seeing the inside the black box of the digital twin. You see all the nuts and bolts and how are they built, what are the thinking behind them and how they function. And this should facilitate faster adoption. So it should be easier to take investment decisions in the concerned organizations. And all in all, we aim to create economies of scale for all the participants involved and facilitate optimization of your resources, which we know they are stretched nowadays. I'll stop here. Thank you.
Thank you very much, George, for setting the scene. You will stay with us for a little bit longer because we will have a short panel discussion at the end of the first block with you as well. So here I take the chance to let you know that if you have any questions, please use the chat or the Q&A function. So then in the panel discussion, we will have all the speakers from the lineup. So then we will be able to use your questions and take it with the speakers. So moving forward with the agenda, TwinEU is really, as you could hear, let's say on the borderline of energy and digital areas. So because of that, we thought we would like to see the scene also from policy point of view from the digital side. So we have here with us Svet Mikhailov from DG Connect, who is a policy officer there. And Svet, if you would like to share your screen. We don't hear you, Svet, if you are trying to.
I'm not talking. I was trying to share the screen.
Okay.
Share screen. Here. Do you see it now, or?
Yes, if you can maybe make it full screen, then it's perfect.
Yeah. I will. Just a second.
Thank you.
I'll put it in presentation mode, hopefully. Do you see now in presentation mode or not?
We have it in a presenter mode, but we can follow it like this.
Yeah. Okay. No, it's okay. Then just maybe here. I'll just switch the slides here on. So yes, good morning. So my name is Svet Mikhailov. I'm from DG Connect, yes, the area of Internet of Things, and we've been also involved in preparation of this call for the TwinEU and all the other things that we're working together with George and his colleagues. I'm going to be talking about, the title is called Standards and Policies for AI and Digital Twins. I'm going to be focusing on different drivers and backgrounds in the digital area, and of course mentioning also the energy, and then some activities which are relevant, standards organizations, and so on. So if we look at some of the policy lines that are guiding us, so we had a data strategy where here I'm starting from the point that we need the data in order to create a digital twin, and then to use AI applications, and to use AI to create the twin, and to use the twin. So in order to get to this data, the data strategy, which is one of the strategy of DG Connect, we were talking about establishing single market for data, so the possibility to move data from country to country around the continent in a very transparent way, easy way, and then data sharing and fair and clear rules of data use and access. within it and within the next thing, the Digitalization of Energy Action Plan, which is of course together developed with DGNR, we had mandated or announced the creation of the Common European Energy Data Space and other activities. And then what is upcoming and also is relevant is the AI Continent Action Plan, which within it, the Apply AI strategy is meant to boost integration of AI in strategic sectors, such as energy. So we're looking at what can be done, what can be implemented using the AI technology within energy, mobility, and other areas. And then, of course, what do we need in order to do it? What kind of computing, infrastructures, and so on in cloud and data do we need? When we talk about the energy data space, and again, I say this is very important because this is where you're going to get the information in order to create a digital twin and to make it useful, especially when we're talking about, in the case TwinEU, about a European digital twin. And there we had preparatory actions to prepare the data space, 5 innovation actions and 1 CSA to combine their efforts. And of course, apart from creating their own data spaces and running pilots, they prepared the blueprint for the deployment of the Europe-wide data space, reference architecture, and other data such as building blocks, governance, etc. And defining use cases, which use cases was also partially mandated already, the top use cases in the Digitalization of Energy Action Plan, for example. Then now we are starting with the deployment action. It has been the grant agreement has just been signed. So it will start from 1st of April, where 54 partners headed by an Austrian coordinator will establish the data space federated architecture, develop standards, standardized data formats, security protocols, and so on, secure and trusted data exchange. And they will deploy use cases. So the scale is already big in 15 EU countries on energy efficiency, flexibility management, no surprise there for people involved in energy, renewable integration, electromobility, and so on. And then I'm mentioning this because these are deployment action and they're very, very relevant. And I'll show you in the next slides how they're relevant for the digital twin and the AI. They're very relevant for you because you are a research project where you'll be able to deploy, where we support the deployment of technologies that you develop, the twin that you developed on a European basis in deployment, in commercial service. So another related action, also a deployment action, but in the Connected Europe facility, because this deployment action, the first one is in the Digital Europe program, and the second one is Connected Europe facility, 2 different programs, where we are deploying the so-called operational digital platforms, IoT platforms, so AI services as well, within the energy and mobility trust. But this is digital deployment. It's about digital network within the energy and the mobility areas. And then there is another one also. This one is also in the Digital Europe program, the Common European Reference Framework, and maybe many of you are involved there as well. It's one that is supporting an application that will be managing the flexibility of the customer and so on. And then when we talk about governance, this is a bit hidden now. There is a Smart Energy Expert Group, which will be dealing with several things, including the governance of the Common European Energy Data Space. If we look purely at the deployment project that was mentioned above for the data space, I'm not covering all the scope. I'm just showing the scope that is relevant for digital twin and AI. So they're talking about integration of AI capabilities, digital twins, data-driven services, and edge computing in the context of smart grids and distributed energy systems. So when we talk about digital twin, it's data-driven digital twins and flexibility functions for characterizing the energy flexibility of both electricity and heat grid at DSO level, data-driven operations using local and data-driven digital twins for sector coupling and market participation, optimized infrastructure planning by using digital twins, and digital twins of the electricity and gas networks. Then AI-driven services, AI advancement, AI factories, accelerate and strengthen the adoption of AI technologies in Europe, naturally, and then deploying AI for the power grid optimization. Then if we look at Begonia, the project within the Connected Europe facility, which is deploying these operational digital platforms. It's a CSA. Well, this is a CSA preparing the deployment. So I would encourage you to get involved with them and then plan with them what will be deployed in the follow-up work project, because what is deployed, what is planned within this project will already define the work project. And then, of course, you can already influence with the results what can be deployed there and include yourself in the consortiums for the upcoming project. So the main objectives is to identify and shortlist the energy mobility use cases that could be funded in this works project, proposing operational digital platforms or IoT type of platforms be distributed or centralized for deployment, and providing input to us in order to write the work scope. So it will be defined the very project or very narrowly around the project that will be selected, more or less knowing who and how will be deploying it. So AI services in the operational digital platforms that they have foreseen in the use cases that are there now. At the moment, there are 6 use cases, starting from 14 or something down to 6, and they're going to 3. And to be honest, looking at how the ranking is happening, probably exactly the cases of energy, electromobility, charging, these kind of things, flexibility, and so on, will be in the top ranked ones. So we're talking about load and renewable energy resource forecasting, demand side flexibility calculation, capacity calculation, predicting the behavior of electric vehicles and electric trucks at cross-border level, because one thing to be said here is this project is about cross-border communication, routing services. And when we talk about digital twins services in the operational digital platforms, is developing the digital twin of the grid and planning and operational services, so flexibility and ancillary. Developing the digital twin of the systems such as data centers, in the use case related to data centers, to propose optimal planning and operational solutions. So you see that there are opportunities here as well to fund the work that you have done in digital twins. And then what we're talking also is, this is upcoming in the next programs. There are a number of calls that we're preparing, etc. We'll see what instruments we have in order to do it, but what we have envisaged is the so-called digital spine of the EU energy system. So this is a kind of a digital layer that be overlaying the digital service, connecting grid and other renewable resources at the edge and other energy possible resources on a unified layer, which will be powered by, then we're moving into upcoming area of AI and generative AI for foundational models, etc. And then you see that we're starting from the power of generative AI using digital twin and the energy data space in order to address supply demand side optimizations and other services here, harness flexibility, carbon footprint, empower the consumers, increase the security of the energy supply, reduce the prices of electricity and energy, support the EU supply industry, and so on. So here, as you see again, for this upcoming digital spine of the EU system, digital twin is playing a very important role. And this will be what the upcoming is for the moment, is more into the, again, research and piloting phase. But there will be probably coming projects for deployment in the future. And then we just, when you see that kind of the model that is developed when developing standardization, etc., this is just one way of presenting it. But when we have the IoT, so cloud edge IoT, the digital twin is working on it. And then all this can be connected. This is the underlying layer, that is the instrument that can be used via platforms and tools, minimum interoperability mechanisms, through the data spaces by some AI-based analytics, etc. And there's some examples in the standards organizations, which I'll show also separately in the slides, but we're talking, we have to support semantic interoperability, for example, and there we have developed the SAREF ontology, but one example would be that the JRC code of conduct for smart appliances, which is promoting it, that was developed recently. We're talking about the minimum interoperability mechanisms. As I said, this is the kind of loose connection, but sufficient between the different layers in the interoperability, which was developed first for smart cities, but now it's coming into energy, and it was standardized by ITU-T SG20. Then supporting reusable building blocks, architecture patterns for cloud and edge compute. This is the SC41 work into architectures. And then we're talking about not just having standards on paper, but also in an implementable way. And there comes the open source, the Eclipse Foundation, and some building blocks for digital twins like PASIX, etc. I mean, not going to list all of them, but you see, we would like to have standards, okay, grammar agreement, but you also have it as an open source implementable thing, and also something fast evolving rather than something every 3 years or 4 years of very stubborn standards, etc. And then just go through some of the different standards organizations that we are working with in order to make sure that the EU results from the projects are promoted there, become their standards at the same time that we are also using their standards, aligned with them, and so on. So kind of two-directional. And I have personally participated now in all these groups that I'm going to show you, all these standards organizations, not all the groups, in order to promote this approach and to promote the results of our projects. So one is the ITUT, Study Group 20, which is on IoT. Again, I'm coming from IoT, so these are the groups dealing with IoT. Digital twins, as you see in the names, and smart sustainable cities and communities. They have a whole series of standards and reports on digital twins in cities, energy, transport, metaverse, water, etc. Of course, I'm not going to listing them all. It's a big number of specifications, but what they're working on now is one on architecture of the digital twin system in power grid. And this is quite relevant for the TwinEU project and the results from it and the involvement. And then there is, as I mentioned earlier, standard on the minimum interoperability. There is a typo here, interoperability mechanisms or MIMs. Then we're going into ISO-ISC, where in JTC1, there are several groups dealing with relevant things. If you look at SC41, which is the one on Internet of Things, and again, digital twin, you see everywhere in all these international organizations. Internet of Things goes with the digital twin. This shows the importance and the interconnection between the two. So there are some work on vocabulary, concepts and terminology, use cases, reference architecture, maturity model and guidance. All this is about digital twin only. Guidance on connection to data spaces, extraction of data process, so on. So all these things. Then SC42 is artificial intelligence. Again, different developments in the area, not to lengthen too much the presentation. And SC38 about some interoperability issues. And then just to mention the other European international kind of duo, which is ENTSO-E, together with 1M2M. So 1M2M again is the IoT, whereas we have smart M2M in ENTSO-E, which now will be transferred together with some other groups into a new group, data group. So there, on one side, we're looking at what they developed for so many years on SAREF. And there was recently an STF that the Commission funded, it just finished, an STF on SAREF and digital twin. So you see that a connection again, action grant by us. There is, of course, SAREF for an air, which you all know, which is relevant. There now works in order to use AI for development of SAREF and evolution lifecycle in order to speed it up and make it more relevant, up to date, fast evolving. So AI evolvement, but for something else, for development of standards. And there is SAREF user group to stimulate industry adoption. And then there are a number of works and specs, like on digital twins and AI. Here's just some examples. So digital twin communication support in 1M2M, communication requirements for digital twin, emphasis on semantic interoperability in cross-sector energy optimization, a reference architecture for digital twins. And then when we go in AI-driven applications in digital twins, including data management for AI use cases and so on. AI as a critical component for enhancing the capabilities of digital twin, AI algorithms used for dynamic data analysis and so on. Again, this is information that you can easily find, of course, with a little search. The idea is, the presentation is, we are working on all these organizations and we count on your help. And I've been personally with a number of projects going, as I said, to SC41, for example, I went and organized the workshop there. So we can think of some things where, because I'm sure you can have a lot to contribute and we want you to contribute, we want Europe to contribute and to have it implemented. So first of all, look at the implementation possibilities that you saw we have in Digital Europe program, in Connected Europe facilities and otherwise. And then let's work together to create single standards on a European and preferably global level where we are in the lead. We can do it. We have the capacities. Let's go for it. I think this is, thank you very much for the opportunity.
Thanks a lot, Svet. One can see that there is a lot going on in this domain, and I think just referring to your final words is that I think within the TwinEU consortium there is a lot of openness to work on such standards together, because that's also in the interest of the project and the project partners. Okay, moving onwards. TwinEU is now a little bit older than 1 year, so we already have a couple of early results, which will be presented by Ilias Zafiropoulos, who is the technical manager of TwinEU project. So, Ilias, the floor is yours.
Thank you very much, Laurent. I hope you hear me well. Good morning from my side. Thank you very much for the invitation. So I will try very briefly to present you, let's say, the first results, the first outcomes that appeared in this a little bit more than 1 year. So next slide. So TwinEU at a glance, TwinEU aims to create a concept of the pan-European digital twin, as had been mentioned before, based on the federation of local twins in order to enable the reliable and resilient and safe operation of the grid infrastructure, while of course facilitating new business models that can accelerate the deployment of renewables across Europe. It is a very big consortium, and it aims to carry out 8 pilots of digital twin technologies in 11 European countries. During this first year of the project, of course, there are preparations regarding the demonstrations that will take place. However, we have also tried to identify digitalization challenges and systems needs, and also define clearly the use cases that will be demonstrated from the federated digital twin architecture. Our approach for identifying challenges and opportunities it has been twofolded: desktop analysis of past and ongoing Horizon projects, and of course, we try to elicit the stakeholders' feedback. Next slide, please. So regarding the analysis of project, we try to group them in specific focus areas. What has been their primary scope, their primary target regarding flexibility and market participations with integrated platforms, data sharing platforms interoperability, cybersecurity and resilience of the energy systems, focused on grid operations, asset management and infrastructure resilience, projects that deal mainly with decarbonization and enhanced renewable integration, as well as presenting innovative tools for energy services and markets. Next slide, please. So from the project analysis, some challenges that we have identified. In most of the projects, there have been challenges regarding data privacy and security. There were several, let's say, alternative solutions provided. Challenges that has to do with technological complexity, which is practically the integration of legacy and modern systems, especially in the power grid. Interoperability, challenges for interoperability and standardization. Data models and ontologies are proposed in several projects. Also, it was mentioned before in the previous presentations, to cope with different vendors and different technologies that can have to be integrated in the grid. Next slide. Also, there have been some regulatory and policy barriers found as challenges. It was identified as low incentives for grid modernization. Mainly, the regulation is CapEx-based regarding the reimbursement of grid operators. Difficulty to set up regulatory sandboxes in order to run, let's say, extensive simulations. Different maturity level of the markets across Europe. So there is, let's say, these differences that have been identified in some countries. Also, challenges identified in the project have been the market acceptance and the stakeholder and user engagement. Some, let's say, there are difficulties in engaging end users and consumers in smart grid technologies, where there are not obvious or measurable benefits for some of them, or some end consumers show inertia to change their habit or disrupt practices, their daily practices. Also, some challenges that have to do with investment costs, high upfront costs by end consumers regarding digitalization of their installations, and no clear subsidies and estimations of return of investment. These are, next slide, please. However, at the same time, where we have challenges, there are also opportunities to overcome these challenges. So there are opportunities certainly in this environment for smart grid technologies and smart technology innovations, especially taking advantage of the fast pace that the data science and the computer science and information technology is going. So these can be very well integrated and adapted in the energy market, in the power grid business processes. Also, opportunities for new relevant standards and technologies that can enhance data exchange and interoperability in order to integrate more flexibility resources and new flexibility services. Also, opportunities for sensor-based devices and technologies that can provide real-time monitoring and control of the grid with high granularity of data collection, also taking advantage of computational efficiency and big data management in order to achieve grid stability and predictability on renewable fluctuations. Next slide. Other opportunities are also for cybersecurity and data privacy solutions. They can also support, and they are very important for the resilient transition of the grid in the digitalization area, and also opportunities for digitalization and data analytics that can support the flexibility resources from distributed energy resources across the grid. Next slide, please. Also, there are opportunities for new market mechanisms and new business models that can come up from digitalization services, as well as the sector integration priorities that can mobilize new revenue streams for businesses. Also, opportunities for promoting collaboration and consumer engagement. All these new challenges are developing in a good environment in order to promote coordination of system operators among them, and of course with market participants and end consumers in order to facilitate this new environment. Next slide. So we also carried out some questionnaires, let's say, in order to retrieve the feedback from energy stakeholders regarding their current implementation of digital twin and their expectations from the functionalities from the digital twin. Regarding the current implementations, there have been several answers regarding implementations in grid analysis, asset management, system operations, market modeling, and interoperability with legacy systems. However, also the expected functionalities from the digital twin are even more. Stakeholders expect to see high performance, accuracy, scalability, user interfaces, and visualization. This has been identified. Next slide, please. Other expectations that have been expressed by the stakeholders is enhanced data integration from the digital twins, interoperability, cybersecurity and data governance, detailed modeling with machine learning integration, observability and controllability, federation of digital twins that is also expressed, scalability, model validation, sustainability and environmental considerations. Next slide. So having this in mind, we are formulating some recommendations for the rollout of digital twins in the energy market. First of all, the establishment of common protocols as have been identified. Standardized data formats interoperability will facilitate data spaces in digital twins. in the energy as well as in other sectors, because energy is also correlated with other sectors like mobility sector, for example. Also leveraging big data to ensure efficiency and resilience of the critical infrastructure. Also, the decarbonization targets and the bidirectional flows require the coordination of all energy stakeholders and their engagement in participating in this energy balancing challenge. Next slide. Also, the digitalization of energy sector requires cybersecurity measures, data protection, especially cyber shielding of the critical IT and OT infrastructure that compose the energy grid. So, smart grid cybersecurity framework should be very well established, and this is also on the way with the respective regulations that are taking place. Additionally, the infrastructure upgrades of the grids can be accelerated with the use of digital twins, since they provide a very efficient testbed for facilitating scenario studies, contingency mitigation, and also efficient training of the personnel in several different to overcome several risky situations, opportunities for a new, secure, and cost-efficient way of operating the grid. And finally, there are also the modernization of the electricity grid can be accompanied with targeted incentives for grid operators to favor digital innovations. They can improve their business processes, and also they can be an alternative to CapEx-intensive grid upgrades. That's all from me. Thank you very much.
Thank you very much, Ilias, for this great summary. When we started TwinEU, actually in parallel, as you could see in the slides of George, there was another work stream started with ENTSO-E and the DSO entity. So we have here Sidesh Gandhi and Stefan Gross. So Sidesh, tell us about how you are doing with the digital twin workstream with the two entities.
Right. First, good morning, everyone, and thank you for having me. So today, so my name is Sidesh Gandhi. I work with ENTSO-E as a senior innovation specialist, and today I'm going to give you a brief on the first milestone from the joint task force between ENTSO-E and DSO Entity on digitalization of energy action plan. And today, as Laurent explained, I'm joined by my DSO counterpart, Stefan Gross, who will also speak towards the end. First, before I present brief insights, maybe intro to the work. The Digitalization of Energy System EU Action Plan project is a collaborative effort between ENTSO-E and DSO Entity under the framework of Joint Task Force. And this initiative, as mentioned by George early today, is driven by European Commission's Action Plan for digitalizing the energy system. So basically, there are two major goals to our project. One is that we want to develop a digital twin of pan-European grid with adequate granularity. And at the same time, the second goal is to develop guidance and support for system operators on sustainable and cost-effective investments. And this is to be done by tailored smart grid performance indicators. So you can see on the screen that the project framework is for the 2 years time span, and the scope of the project is limited to supporting the digitalization by creating a framework or a foundation which will identify work streams, specify business requirements, challenges, enablers, digital twin solutions, and finally a roadmap. The project does not intend to release applications or platforms, as you know that the lifespan is quite short. And I'm happy to announce that the first milestone, which is a technical report on common TSO-DSO challenges and opportunities, will be published this week. And you'll have a chance to dive into all of the results. If I go forward, so based on the expertise we had within the joint task force, we started our work under three major clusters. One is customers, business, market, and information exchange. Second one is system planning, flexibility, and asset lifecycle. And then finally, system operations and control rooms for future. So within each of these clusters, we have a high-level goal, right? And how did we come up with these high-level goals? So there was a lot of bottom-up and top-down assessment of challenges to understand what are TSO-only challenges, what are DSO-only challenges, and what are common TSO-DSO challenges. And we also try to analyze those challenges based on urgency. So in the short term, medium term, long term, and we also try to understand what is the overall impact and complexity. So what is the effort required to implement those challenges? As I said, due to the time limits, I'm not able to deep dive into those challenges results, but I also invite all of you to look at the joint publication, which will be published this week. If I move forward, so there were a lot of digital twin initiatives which were captured in the report. If I recall, there were 37 different digital twin initiatives which were employed by TSOs and DSOs that we captured. Some of those initiatives look at specific assets or specific use cases, and those are basically local digital twins. Some initiatives are more looked into, covering entire transmission network or distribution network as a whole. And then there are some initiatives which are, collaborating with multiple TSOs and DSOs to develop interoperable digital twins and standards. So we try to organize all of the digital twin initiatives into, I think, 6 or 7 different application areas is what you see on the left-hand side. The main key takeaway from this slide is that we see highest maturity in system operations and operations planning. And I think partly this is because a lot of work was focused on dynamic line rating. So adjusting the capacity of transmission grids in real time to optimize the power flow and increase efficiency of transmission without overloading. And then we see a lot of highest maturity also in grid optimization and asset health. So this is mostly in the phase D, which is diagnostic, or phase E, which is predictive analytics. Again, this is a result of tremendous work done in the past on predictive maintenance. And then we also see other application areas such as grid and market modeling. So there were digital twin initiatives which looked into pan-EU scale market modeling or detailed substation level modeling by TSOs. Or you can also think about initiatives at the low voltage network. And these are quite innovative in the sense that they use AI, street view imagery to map low voltage assets, as well as the data from smart meters. Again, you see a different application area related to BIM and 3D modeling. Then there's also real-time monitoring and control, where initiatives look into advanced real-time sensors, focusing on stability, whereas DSOs, they are more focused on customer monitoring. So if I move forward, what are the main conclusions from the first milestone? Again, similar to what Elias covered in the previous presentation, there are a bunch of technical barriers which are common to TSOs and DSOs, and then there are cross-cutting barriers. some of the common technical barriers we see for both DSOs and DSOs. They deal with reducing errors in forecasting, for demand, production, and grid capacity. And then there is also a lot of focus on extensive grid modeling and prediction. And then there are some other cross-cutting barriers. And so it's important to have a collaborative approach amongst industry, policymakers, system operators to maximize the potential of digital twins by incorporating harmonized data formats, interoperability standards, and strong cybersecurity related measures. So I highlighted a few cross-cutting barriers, but then there are also a lot of opportunities. So we try to integrate a lot of renewable energy sources so that consumers can cash in on their flexibility assets. And then we also utilize innovative solutions to optimize the power flow and safeguard society well-being with a cyber secure power system. With that, I think I will give the floor to my colleague Stefan to also present the work on the DSO side.
Yeah, thanks to Dash. It was a comprehensive summary of our joint work. I will be very swift. I have just a single slide to clarify actually something. So everything which Sidesh presented is our joint work. Maybe you saw that like 2 weeks ago, we largely announced that actually DSO Entity is starting its own DSO or digital twin project, the so-called DSO for DT project. That was born out of the opportunity offered by the Horizon project to apply for some additional funding, specifically for DSO Entity. And we took this opportunity and applied for this funding and received the funding. What is very important for me and for us here is to outline that this is not a work which runs in parallel to the work we already established with ENTSO-E and with Sidesh and DECODIT, but this is like completing it basically, and it brings a little bit different perspective on the digital twins from the system operator side. It will focus, of course, more on the DSO side, but in the end, this is also a joint work effort with ENTSO-E, and we will still work jointly with ENTSO-E also within the DSO for DT project. If you want to see it a little bit on a higher level, I think that our work so far with Dash was more a bottom-up approach, where we really got into the challenges and opportunities as presented by Dash. And I think we are now going the other way around with the DSO for DT project, where we want more to go what solutions are already out there, how are they used, and what are the coming from existing solutions, which is more the top-down approach. So in the end, this will all smoothly run together, and I think the digital twin activities throughout Europe have the full support of the system operators for both sides, actually. On the right side, you see a little bit the key objectives. I will not introduce them. If you are interested, I hope you were all in our webinar 2 weeks ago. Otherwise, on top right corner, there is the link to the webinar, and feel free if you have any questions to reach out. The main message is that ENTSO-E and DSO Entity are working closely together on this topic. We'll do this in the future. So have a nice. Thanks. That's all from my side.
Thanks a lot, Sidesh. Thanks a lot, Stefan. So Stefan will come back a little bit later in the panel discussion for the second half of this webinar. But Sidesh will stay with us right now because we still have some time for a short round of panel with the speakers that we had so far in this part of the webinar. So I give the floor to István, and I would call George, Svet, Ilias, and Sidesh to come back. And if you have some questions, please let us know so we can post it to the speakers.
Thank you, Laurent, and thank you guys for the presentation. And I'm really happy that so many people joined us. It shows that this topic is more than interesting. It has a real highlight. So I encourage you to, if you have further question or anything to clarify, feel free to add on in the chat window at least. And if we don't have enough time here now to provide the answer, we will definitely do that via electronic channels and on our website. So I have 10 minutes, guys, altogether. So I will jump into the topic immediately. The questions are for almost all of you, but I guess you will feel that who is closer then. So the first one is the next. How do the first steps of the digitalization of energy action plan look like? Is there a need for any new policy or funding to boost this area, or it will be a bottom-up approach? What is your stomach feeling?
Can we just step in or raise hands or?
Please, come on.
Okay, thank you, István. You mentioned the action plan, and we are in full swing of the activities that touched upon some of them. I was mostly focusing on the investment part. I presented progress there. We are making a lot of progress, which is good. But the work on digital twins in particular, it's a multi-stakeholder and a step-by-step approach. So we need to make these further steps. We are looking forward to the first main deliverables. So the roadmap from the task force and from the conclusions from TwinEU, from DSO for DT, and so on. There's also good progress on the indicators that we hope to spur to help the investment challenge. But looking ahead, and there's the work stream on data that was mentioned by Svet, so I'll not go into that direction. We have quite a few things happening there, but I wanted to focus on what's ahead. And on that one, I look forward to hear from all of you, from the participants in these work streams, what should be next. For instance, how the roadmap developed by the task force should be implemented. What's the role of the grid operators? How the public policies could help, and so on. How do we deal with funding? And we have quite a few good ideas, but we look forward to hear from you. What research and innovation actions would be needed to deepen in certain areas, because innovation never stops, and we have good mechanisms to do that. And we mentioned HorizonEurope as a key factor there, and we have Digital Europe for deployment. There are these clear themes that were mentioned. We knew we have them in the policy documents: the cooperation, the need to cooperate, knowledge sharing, having coherent approaches, building communities of practice. Those are clearly important. Investments are essential, of course, to make everything work, and we need to unlock them. We need to sort out technical details, and this is what you guys are working on, to have consistent approaches, look at interoperability, have access to data, and so on. Ultimately, to create the economies of scale I was mentioning. And for this one, the good news is that the Commission, one of the good news is that we have funding available, and the Commission is preparing a new strategic roadmap on digitalization and AI in energy. This was mentioned in the mission letter for our new commissioner, Jorgensen. Also, grids package is being developed. So there are a raft of policy actions coming up. These will be published in the first quarter of next year, so still some time to reflect. And for that, your recommendations for future policies are very welcome. So I urge you to put them forward. Send any ideas, written feedback, position papers, and they will be given due attention, or quite a lot of attention, coming from US practitioners when we prepare the next policy action. So there's room to improve in the future. It's clearly that we are not solving the world in 1 day. We are expecting huge step forward with these actions that we are having today, but it's not the end of the day, not the end of the road. And we'll build on those, and we look forward to hearing from you how to do that. Thanks.
Thank you, George. I would like to bond on that thought what you mentioned. So not only the technology based on the digital twins, but the AI technology is a tremendous emerging something as we could identify it in the United States or now in continental Europe and worldwide. What do you think the stricter AI regulation will slow down the innovation in digital twin and the energy area, or it will be a trigger to support a more robust but trustworthy solution and a faster development and enhancement?
Yeah, probably I can take this.
Thank you, Seto.
So the first to say that, okay, I'm replying from DG Connect, but from Internet of Things point of view, legislation is prepared elsewhere in DG Connect for AI. Having said that, and I'm also completely, from my position, I'm completely behind the innovation and developing more. This is what we are aiming at. Now, having said that, of course, we cannot, first of all, there are many interests and there are many people that are vulnerable or many other aspects that could be vulnerable. So we have to take everything into account and address everybody. And therefore, of course, we cannot leave it as a fenceless piece. We have to put some fences around it. And also, by doing this, of course, we're going to increase the trustworthiness of the solutions. This, of course, should lead to wider adoption of the solutions. So we shouldn't perceive regulation as something that is hindering innovation, but rather that is fostering it, because increasing the trustworthiness, it's also preventing anything from disrupting the system. And therefore, I would say that carefully designed legislation will be pushing innovation rather than hindering it. And in order to achieve this, of course, the Commission is working with a wide range of stakeholders from all walks of life, etc., all sides, all involved partners, in order to make sure that the requirements of everybody are met without jeopardizing the interests of the other parties. So finding the optimal solution. And that's why sometimes it takes a bit of time to create this kind of regulations and legislation. But at the end, we believe that it will be the best for everybody, that this will increase the trustworthiness of the reliability of the solutions, at the same time foster the innovation.
Thank you, Sato. As we are running out of time, I would be really fast and ask you to have a concentrated answer. Next one is for you, Sidesh. What is your opinion? This type of technologies and solutions, one aspects for DSO, another solution for a DSO, or they can combine, or they have to collaborate? What do you think?
Yeah, I think it's a good question. So earlier, briefly, I touched upon different approaches to digital twins, local digital twins, integrated digital twins, which look at entire transmission or distribution level. But then there's also a third approach, which is a system of system approach. From a pan-EU perspective, it's important to have a system of systems approach. So basically, there are multiple TSOs and DSOs working together on this solution. And this requires a bit of holistic perspective. We need to use standardized data models, communication protocols, for example, SIM, IEC 61850, for seamless integration of digital twin models. I'm quoting one of the advisory board members from the project, that there's not lack of standardization, but there's lack of use of standards. And this is something we need to tremendously pursue. The last point, it's also important to reduce organizational data silos if we want to scale and foster coordination when it comes to asset management, grid planning, market, or even operational planning. So with that, yeah, I hope I answered your question.
Absolutely. Thank you. Ilyas, a really easy one, last but not least for you. There are 75 consortium partners in TwinEU, so it's a huge cooperation. But there are a lot of members here, attendees in this workshop. What is your value proposition? What is the most promising business model? Why to utilize this technology?
I believe that this technology provides many prospects. Of course, it is a technology, the digital twin technology in the federated digital twin framework. It's a technology that primarily affects system operators because they operate the network. However, this can let's generate cascade effects in all the market participants that connect with the grid, sell energy or services to the grid, manufacturers, industry, and the industry of equipment or technologies that populate the energy grid. So this can generate many different business cases, and however, this can be should be also reflected in the future operations. And apart, I also agree with the rest speakers. I think I would also add another element that digital twins can support the development of the skills of the personnel that will take over the grid, the digitalized grid from the next digitalization era. So this environment can support many scenarios, the development of new ideas, and of course, new competencies of the personnel as well that will take over the grid.
Thank you. A really nice last thought. Without digitalization, I can't imagine our not the future, but our nowadays. Thank you very much, gentlemen, for the excellent conversation. I would be happy to keep on with an hour or more, but we are out of time. Thank you very much, Laurent, for the opportunity. Back to the studio.
Thank you too.
Thank you very much indeed. So after setting the scene and seeing the framework in the first half of this webinar, in the second half, we will see how actually the projects are dealing with this situation, how they are trying to provide solutions for all these challenges that were drawn up in the first half. So, not to lose any more time here. First, in the second block, I would give the floor to Antonello Monti, who is the project coordinator of TwinEU. Professor Monti, maybe you can take over the screen.
Yeah, thank you. I'll try to share my slide. Do you see the PowerPoint?
Not yet. We see the meeting itself.
Okay, let me try again. I unfortunately have to use the web version because my Teams doesn't work anymore. Do you see the slides now?
Yes, now perfect.
Oh, wonderful. Sorry for the little glitch. Good morning from my side. My name is Antonello Monti. I'm a professor in RWTH Aachen and group leader in Fraunhofer FIT Center for Digital Energy. I'm here today as coordinator of TwinEU. I have few slides of introduction. Probably a lot have been already said, I would say, so I will try to skip because of the previous presentation already touching some of the key topics. Let me stress again how large TwinEU is, not only because it's a large budget, but because of the number of partners. So we have more than 70 partners. And what I find really relevant is, as you see in the bottom of the list, we have grid operators that found this operation of working together on a common digital twin or European infrastructure so relevant that they decided to join and be part, even as associate partner, simply because they want to be involved in the process. So I think it's quite unique project in terms of being really European in the sense of number of countries and the number of the grid operator at transmission distribution level that are involved. We have a strategic goal that was briefly mentioned before, but I'd like to stress it again. the focus is mostly on the federation of local twins. We started preparing the proposal with the knowledge and the assumption that efforts were on the way in the different grid operators to develop a form of digital twin. And what was important is to make them interoperable, to make sure they could work together so that we can build a federation of those local twins. We see this as a great opportunity to facilitate new business model, and the overarching goal at the end is to accelerate deployment of renewable energy sources. We have developed a quite structured architecture and vision for the project from the IT perspective that you can summarize here in the slide. I start from the bottom. We have the physical devices, which are also the data sources. Those are feeding the local digital twins. Those digital twins are federated, and that's one of the key technology that the project will develop. And thanks to the federation, we are able to offer a variety of services thanks to a service orchestrator, which will bring a lot of capability in terms of model sharing, data sharing governance, data integration, homogenization, all that making use of a lot of previous work in previous European projects and other large effort, like, for example, just to mention Gaia-X. All that enables also, let me say, the top part, which is the possibility of third-party access, so making possible for other stakeholders to access this European level digital twin. And this is a key point to create new business model related to digital twin. A very important point also about TwinEU is that we build on the shoulder of a previous project, which is OneNet, and OneNet delivered the first data connector for the energy sector. It's called OneNet connector, and a set of tools, again, based on decentralized middleware, which are the standard building blocks around which the federation that TwinEU is developing can be built. In the project OneNet, the focus was on flexibility. So everything that was done in relation to connector was supporting use cases in the framework of flexibility. Here we are expanding the capability with the goal to support vice versa the digital twin, so gain direction of model sharing and so on. To be concrete, I like also to mention some of the demo, and of course, as you heard, there are a lot of demos because of the large number of grid operators. So I mentioned just few of them to give a glimpse of the variety of use cases that we will be able to explore in the 3 years of the project. I start here with some reference to the Italian demonstration. Here we have an interesting data challenge in integrating data models related to energy sector, for example, common information model, with data models like BIM related to physical infrastructure, with a goal to have complete 3D modeling of components. Let's say it could be, as you see also in the picture, a substation or any other infrastructure that a grid operator may develop in the future, with the goal at the end to have a virtual behavior simulation that can also be used also in other studies, so linking to the grid model and dynamic grid model, assessing, for example, pre-qualification of DR interacting with the system. So it's a comprehensive view starting from high-level visualization and the 3D topics to more strict electrical topic like pre-qualification of DR. This is what will be assessed, for example, in the Italian demonstration. Another important point that I'm mentioning here is the German demonstrator. Here we're looking vice versa on how the digital twin can support flexibility and network planning. Here, the focus is a lot on the interaction between the TSO and the DSO. We have two relevant players of the German system, Amprion for the TSO side and Westnetz for the DSO side. And the goal is the creation, developing, and testing a digital twin of the electricity grid to support dynamic monitoring, so bringing monitoring to a new level, smart grid planning, forecasting, and scenario analysis, and all that having in mind use cases like congestion management, and then exploring in that respect data exchange between TSO and DSO. This is a process in Germany has been already running with the previous German level projects, and now we are bringing here together the knowledge from the German projects and the knowledge of the previous Horizon project like OneNet, and bringing them together in a more in a wider picture. Here we have a reference to vice versa, the demo in Slovenia. Here we're dealing really with grid operation, vice versa. So we are moving more towards the real-time part, dealing with, on one hand, static analysis, in particular grid condition after critical network event, and also dynamic assessment. And that means real-time assessment to forecast dynamic stability. What is relevant here, that's the reason I added this other use case, is that part of this analysis will be enabled by AI algorithm. So that will be also an opportunity for TwinEU to look at how a digital twin can provide data that are usable by machine learning and AI algorithm. Different use case, again, here moving to Hungary. Here we're dealing with virtual sensor for transmission line monitoring. Again, another case here of AI application, because we're dealing with artificial neural network based digital twin for power line sensor. And the benefit here is an accurate thermal monitoring that allows us to reduce hardware costs and to increase the grid flexibility in the system. And so we move from physical sensor to increased knowledge based on virtual sensor, which are AI driven. So in conclusion, I think I can claim TwinEU is a quite unique project for ambition and complexity. And we have the aspiration really to have a real impact because of our size and the number of actors we are involving in the work. And what is also relevant, I think, already from the day of the proposal, we had in mind a strategy to go beyond the funding period, linking the work we are doing to the CRESIM Foundation, which will be able to maintain all the open source tools that will be developed, and making sure that grid operators and research institutions will have a long-term way to cooperate on whatever is developed in the project, also when TwinEU will be over. And that will be based on a structure which is the CRESIM Foundation, which is already there, and they will be able to keep up with the work, with the cooperation among the actors that are interested. I think with that, I use my slot of time and I give you back the floor. Thank you very much for the attention.
Thank you, Anto, for the presentation. We will have you back also at the panel discussion. And in order to have some time for the panel discussion, actually, I would like to ask the upcoming presenters to try to be efficient with time. So our next speaker is Dune Sabilo, who is representing the Bridge Data Management Working Group today. But she is actually a smart grid and interoperability expert working in Trialog. So Dune, if you could share the screen.
Okay, can you see my screen now?
Yes, perfectly.
Okay, thank you. So thank you for the introduction. I'm Jane Sebiu from Trilog, and I want to talk about the standardization around digital twin from the point of view of Bridge, the Bridge initiative. So just a quick word about Bridge. It is an initiative focusing on the gathering of results from European project. It is divided into 4 working groups, and especially we focus here on what is done by the data management working group, especially in the actions around the reference framework and the Bridge standard user group, which are very much, I think, related to the standardization around digital twin, and can help enhance the adoption of standards around digital twins. So around the digital twin standardization, I think there are 2 main perspectives that are quite important. The first one is the horizontal approach that is very much supported by the GTC1 and SC41. These horizontal standards have a very high-level top-down approach, and are aiming to build foundations and the common ground for the digital twins. So there is, in particular, the IoT and digital twin standard that was published in 2023, but also a lot of ongoing projects, and also some cooperation with other committees and organizations in order to really encompass the full picture of digital twins. And then you have the vertical approach, which is more supported by the SIG Smart Energy organization. This one has a more bottom-up approach, and is working on collecting inputs from what has been done on the field on existing application that develop digital twins. So they are collecting this information in cooperation with different technical committees of SIG Smart Energy. And the idea is really to understand what is being done in the field. And so there is also a lot of cooperation going on between these 2 approaches in order to sort of meet in the middle. So regarding the horizontal standards, there are a lot of work going on at the moment. So I won't go too much into the details, but here you have a list of standard. The green ones are the ones that have been published. The yellow ones have already a draft available, and the red ones have some preliminary work done. So there's, as I said, the GTC1, SC41 on IoT and digital twin, that is more focusing on the architecture, terminology, use cases, and then you also have actions from the GTC1 SC27 on the first worthiness of digital twins. Yeah, so that's probably not an exhaustive list, but just to say that there is a lot of activities going on in standardization around digital twins. So a few interesting results from these horizontal standards is first this conceptual model of digital twins. So you can see here that we have the digital twin that represents a target entity with some synchronization between the 2, and each takes context from observable elements in their environment. Then you have this lifecycle model that aims to take into account all the steps of the lifecycle, both for the digital twin and its target entity, knowing that the digital twin, a digital twin can be applied to any of the steps of a target entity lifecycle. So many different digital twins and target entities can have relationships. Then for the vertical approach, so the 6 Smart Energy is focusing specifically on digital twins for the electrical energy system based on existing components and projects, and aim to identify how the digital twin can contribute to the energy system, how they can be built, and how they can exchange data. So there has been a workshop, quite an interesting one, that has been organized in September last year. And the recordings are available if you're interested. I will show the slides after so you can access it. But during this workshop, there have been quite a few things that were identified. So the existing systems have been actually using digital twins for quite a while already under potentially different names. So what has been identified from these existing tools using digital twins is that there's a lot of very independent initiatives with very varied methodologies, and they lack especially in the reusing and sharing of data, and also there is no really any formal shared governance on the data life cycle. So that is lacking as well. So 4 topics have been identified to work on in the future. First one being the harmonization of the data models. Second being the identification of tools in order to develop digital twins. Then you have education and awareness, and finally the governance of the digital twin. So yeah, this leaves a lot of open questions, especially around the harmonization, the benefits, and the costs of the digital twin that the 6 Smart Energy aims to work on in the next years. So to conclude with this, we can see very much 2 main approaches, the vertical and the horizontal approach. The horizontal standards working on the architecture and semantic interoperability, whilst the vertical approach works more on the products and existing products and systems. And these 2 approaches coordinate to try to meet in the middle in order to be able to apply architectures and concepts that are very global to the field systems, and enabling the developers of digital twins to be able to use these common grounds to be more interoperable. And this approach can be helped by the EU research and innovation ecosystem. So we have IATI that has a standardization working group. The BDVA has a standardization task force, and in Bridge we especially have a standards user group that has also a liaison group with Sentinel, ETSI coordination group on smart grids, and all these groups try to help concrete projects to apply the standards. So really identifying the standards and helping applying them in practice. So I think that's all I wanted to say. Thank you for giving me the opportunity to talk about this.
Thanks a lot, Dean, for giving us a peek into this tremendous work that you are doing in this working group. I think that's very important and useful and helpful for all the projects that are dealing with any kind of digital twins around the smart energy sphere. So, moving onwards, as you could see in Professor Monti's presentation, TwinEU covers a lot of ground, but TwinEU doesn't really go into the level of end consumers. So for this reason, we invited two projects that do. First of all, we have here the representatives from DEDALUS project. We have the project coordinator, Diego Arnone. But I'm not sure, Diego, if you are in the position to be able to give the presentation. So we have also Luca Vitale with us. If any of you would be able to give the presentation on how you are using digital twins in buildings, yeah, you can take the floor.
Hey, good morning. Can you hear me?
Yes, perfectly.
Okay, yes, thank you, first of all, Laurent, for this opportunity that you are giving me to talk about DEDALUS and how digital twins are being used in this research initiative. As you already said and mentioned, I'm traveling at the moment. I found a place where to stay just for a few minutes, so my participation was not granted from the beginning, and that's the reason why I decided to involve my colleagues, Luca Vitale, because basically prepared the slides and is also the work package leader of work package 4 that is mainly related to the applications that we are developing for the demand response that is the main focus of the project. And these applications include also digital twins. So I will simply present the first few slides just to introduce the project, and then I will leave the floor to Luca. I will try to stay connected till the end of the webinar, but I'm not sure about that because probably I have to move to another room, even because this is, as you can see, is very, very cold. Anyway, this is the project identity card. And here you can see that we are in the very middle of the project because the project started in May 2023 and the duration is 36 months, so it will end next year. The total cost 7.3 millions and the contribution is close to 6 millions, 23 partners and 10 countries as coverage for this initiative. And you can see on the right side, which is the map of partners to European countries. Next slide. As you can see in the next slide, basically, since we have to focus on pilots and how the digital twins are being used in pilots, because we are in the very middle of the development, we are going to deploy our applications on pilot site, and then we will start the evaluation of results very soon. We have 5 front runners that basically are pilots in which we are developing and deploying the applications. Among these applications, also digital twins and 2 multipliers that are basically used to, let's say, explore the replicability of our results. So you can see that the pilot number 1 is in Austria, managed basically by our Power and Greenpoint, Blueprint, Consensus, and so on. So it's in the context of an energy community, and it's a tool for flexibility aggregation for building level energy community. And pilot 2 is in Denmark, and the pilot is basically related to energy efficiency and demand response optimal interactions between district heating and electricity network in social housing. I want to underline that the DEDALUS project is about demand response, but the concept of demand response is conceived in the crossroad of different energy carriers. So basically a building is connected to electricity network, to power network, but in some cases it also connected to gas distribution network and is also connected to district heating network. So we are also exploring the opportunity to exploit the conversion of energy from one carrier to another to empower the flexibility of the residential building sector, since the residential building sectors can, even with a small percentage of flexibility, contribute in a significant way to the, let's say, to the stability of the power network. The pilot 3 is in Greece, is basically related to multi-value demand response for multi-segments of residential energy, electricity and gas consumers. That's the reason why I was talking about gas, because we have a pilot in which gas and electricity are considered as two potential carriers for producing flexibility. And the pilot number 4 is in Italy, and it concerns trading off comfort with energy consumption in demand response programs for all people that are living in serviced apartments. So we take care also about comfort aspects, and UniVPM and this is quite aspect and is doing an excellent work. And pilot 5 is in Spain and concern district level demand response for increasing community level self-consumption while providing flexibility to local DSO. So here we are using demand response at district level, and we want to provide flexibility to the local the distribution system operator. Then we have other 2 pilots, the multiplier. One is managed by Centrica, but is quite new, I mean, because we lost this pilot at the beginning of the project, and now we are trying to engage another pilot in the very middle of the project, but everything is under control. And then in Romania, blockchain solutions for demand response management and flexibility aggregation. We are in the context of a campus of students where the apartments can properly provide and trade flexibility. So we are taking into consideration electricity and energy in different forms, but also non-energy aspects like buildings, like mobility, storage, comfort, wellness, health, also for older people. So I leave the floor to Luca that will simply explain how digital twins are adopted in the project very, very briefly.
Yes, I will be very, very briefly. Can you go next slide? Okay, next one. Okay, the key feature of the DEDALUS digital twin are AI-driven predictive analysis and the integration with IoT devices and the smart grids, with application with consumer flexibility planning, demand response optimization, and energy efficiency monitoring. About energy efficiency monitoring, in the next slide, we are developing a 3D building visualization inside the digital twin by using that Open 3D library. These will help us to interact with the building and see many features of it, like the temperature, if there is comfort, and all the KPIs we are monitoring. We can see large model size optimization through this library. The model is interactive, then it's also easy to use, and you can navigate, you can do nice stuff. And of course, we are integrating also near real-time sensor. In the next slide, we can see we are developing, especially in Romanian pilot, a digital twin model for the students' apartment building that incorporating heterogeneous source with the purpose of supporting decision making in demand response program. The digital twin model is interacting with the blockchain and smart contract solution to facilitate the simulation of demand response action regarding activation of appliance in the context of demand response settlement with smart contracts. The final goal of the digital twin model is to determine which appliance should be activated or adjusted to meet the specific constraint to obtain demand response in the pilot. We can go to the next slide. We are using mainly regression and clustering algorithms. They are ad hoc algorithms with the purpose of to do predictive energy consumption modeling, optimization of demand response decision making, and what we want to do is to improve user comfort and efficient recommendation by doing nudging applications, and of course detect patterns of energy related behaviors. In the next slide, we can see a user-centric design. What we want to do is to do a user-centric design and transparency. We want to build something that is easy and easy to use, and in which the people who are going to use the digital twin trust. And we don't want to make something complicated to empower users. Which are the concrete benefits of these digital twins? Is we want to have better decision making, and we want to have personalized recommendation. We want to have balanced energy efficiency, and we want to improve the comfort of the people that are using the digital twins. Another one is, of course, to reduce cost savings and energy efficiency. We want to lower the bills. We want to have a concrete impact on the users. And at the end, another important thing is the active participation in the energy transaction of the users. We want that the users are active. They do actions every day to obtain this energy transaction. In the next slide, this is just our key takeaways, and of course, we think that digital twin are essential for demand response and energy flexibility. The 3D building visualization, I think it will improve the user interaction, it will improve the monitoring, and it can have a nice impact on the users. Blockchain enables security, automated transaction, and of course the AI-driven models will improve accuracy and energy efficiency. And of course, not least, the user-centric design will help the adaptation of the digital twin into everyday life. Thank you.
Thanks a lot, Luca. Thank you, Diego, for making yourself available in not ideal condition even. We are a little bit running out of time, so very quickly let's move to the final topic of the day, which is the DECODIT project, brought to us by Stratis Kanarachos, who is the project coordinator. Stratis, I know it's a little bit ungrateful role, but if you can make it in a little bit less than 10 minutes, then maybe we would have a couple of minutes left for some questions in a panel discussion with you. Thank you. Stratis?
Definitely, we'll do so. Thank you, Laurent and TwinEU project for giving us the opportunity to present. Yes?
Yeah, sorry,
Hello?
you were breaking up a little bit, at least on my end.
So, can you hear me?
Hopefully now it's okay.
Is it? Okay, great. So thanks, Laurent, and the TwinEU project for giving us the opportunity to present DECODIT. And I would like to thank also the fellow presenters that gave very informative and rich presentations that are very inspiring and give us lots of opportunities to collaborate. I will share my screen in order to give my presentation. So, DECODIT is a European project funded under the CLF 5 2023 D30304 call. It started on the 1st of June of 2024 and it will end on the 30th of November 2027. So we are currently in our 10th month and it comprises 18 partners out of 11 countries. DECODIT's aim can be summarized in mainly three topics. First of all, to address the challenges of energy transitions that are data, and by using data to be able to offer personalized solutions to citizens. Number two, to simplify decision making by offering natural for the users to interact, as we understand that not all users are digitally literate. And furthermore, also for innovative financing, this is one of the main obstacles citizens are facing when deciding about their. And number three, that will demonstrate the project effective energy services aligned with certificated in Greece, in Spain, and we have as an aim bring building energy services that are currently fragmented and do not collaborate with each other in a more collaborative environment in order to offer holistic solutions to the citizens. And number two, the solutions need to be embedded within the citizen energy practices. Otherwise, as we have seen in real life, they will be rarely implemented and just seen as an innovative solution that otherwise is not implementable. The problem we are currently facing, all of us as European citizens, is that the electricity and gas prices have surged. So the electricity and heating are very, very expensive. So most of us are facing a challenge on how to make both ends meet, or at least how to reduce the price, how to reduce the bill we are currently paying. Number two, the volatility in energy markets is exposing consumers to price fluctuations, something that was not present in the past. So we realize that some parts of the day the electricity is much cheaper, and in other cases it's much more expensive. So, but we don't know how to make use of it. So we do not know how to control the volatility. And number three, we really don't understand how to navigate this very complex energy services landscape. We get, we are aware in the best case of many different energy services, but some of them seem to be overlapping or competing, especially when considering a fixed budget. So the solution to this problem, and this is what we are trying to explore within an innovative environment, is DECODIT wants to develop a digital twin of the consumer, of the citizen. You can think about it as a reflection of the energy practices, of the energy journey each one of us is taking every day. And we need to think of this energy journey not separately, but as part of the journey all of us are taking every day, because smart energy or energy is only one aspect we are facing every day. There are many different aspects, and smart energy needs to be part. Number two, we aim to use that to offer personalized customized. In the context of, let's say, economies of scale, we need to have a platform that is allowing to develop the solutions that sequentially or subsequently are refined in order to offer a personalized and customized service. Number three, we need to use the data to interact optimally with the consumer. Not all of us share the same level of digital literacy, or not all of us are more or less trusting innovative energy services the same. So we need to use this data in order to optimally interact with the consumer. And this is actually these are actually the three pillars we believe our solution will make progress state of the art. For your overview, DECODIT is developing data-driven services in mainly three categories. First of all, energy management and flexibility management. Number two, in renovation support. There we have three sub-pillars. It's about green retrofitting, so electrifying, for example, the heating of a building, or installing PV panels. We have the building assessment, which is actually for example, the smart readiness indicator or the energy performance certificate or an energy simulation of a building. And number three, it's the energy efficiency renovations, which are about for example, improving the insulation of a building or replacing the windows and so on. And number three, it's the financing of a home or of a building, where we see also a lot of potential in terms of loan underwriting. By getting more data and having access to more data, it is possible to facilitate better loan conditions or the approval of a loan. And number two, by bundling different projects, by using data from more than one, for example, building or use case, we can offer better risk assessment to those that are providing the loans, and therefore facilitate the investment of particular energy renovations that wouldn't be possible otherwise. All of these services currently are fragmented. They do not communicate. They are provided by different service providers, and what we are aiming at is to facilitate the exchange of data between all these services and use cases in order to offer a holistic solution through the consumer digital twin. And we are currently at this stage in DECODIT. We have more or less identified all the use cases, and we have developed a first set of scenarios, and we are in the position to understand at the very first stage the data exchange requirements in order to facilitate this collaboration. As in many other projects, however, we see a tug of war, let's say, between the benefits of future-proofing homes using DECODIT and the obstacles that are evident. Some of the obstacles we have already identified are, for example, first of all, the lack of incentives. What's in it for me, will the citizen ask? And this is not very clear in many cases. So we, as DECODIT, we are very much interested in understanding what has been developed in other projects beyond our more or less perspective or particular focus in order to take advantage of it. We have data privacy. Of course, we are basing our solution on, let's say, the ground or the foundation of the common European energy data space. However, we need to understand also how this is part of a whole system. We can see, I have mentioned the services fragmentation, the lack of interoperability. So here, as a project, we are aiming to use control vocabularies that have been developed already, and make use of them. And again, we are very much interested in understanding how other projects that have made developments and are feeding our project in the general context can help us with this. The low digital literacy of citizens and consumers is an aspect. The lack of user-centric design in many cases. We believe that we should focus on user-centric design, and technology will come as a solution to this rather than the way around. Lack of trust, and finally, a fragmented financing framework. in general, and this is my conclusion, is let's decide. So within our project, we're to do some developments, and we will be able to move beyond the state of the art. However, in order to really have a greater impact, we need to see how our project can be more or less collaborate with all the other projects that have developed solutions that could feed our project. Thank you very much, Laurent. I hope my connection was relatively okay.
Yes, thank you, Stratis. I think somehow it warmed up, so for the most part we could follow you quite well. So the time is really running out, but we don't want to miss out this opportunity to have you all together. So if the speakers and also the audience don't mind, maybe we can add a couple of minutes to this panel discussion. So I give you over to Selena, who is going to moderate this panel.
Thank you very much, Laurent, and thanks for all the speakers for sharing their valuable experience and insights into the application of digital twins. I'll take the opportunity to ask some questions, but for the audience, again, if you have some, please post them in the Q&A. And I propose to start with Antonello. So the TwinEU project has quite an ambitious goal of fostering the integration of grid digital twins in Europe through the application of a federated model. And the project is as well testing or planning to test some pan-European use cases. And I would like to ask you what, in your opinion, is the added value brought by the federated model to the fulfillment of use cases with a European breadth? But also, what do you think is the added value of aligning with the European Energy Data Space Initiative in this?
Yeah, thank you very much for the question. So concerning the first point, so the multinational, I think renewables are pushing more and more for transnational energy flows. So limiting to the borders of a single country is something that doesn't match with the current situation. So we need this international view because that's what the energy system is going towards. And the reason for data space is exactly linked to this problem. So what is really important in my view from the data space approach is the data sovereignty principles that you can embed in the principle of using the data connectors, which make sure that all the possible data exchanges within all the possible stakeholders are respecting the requirements of data sovereignty and then the corresponding privacy issue that could be connected to it.
Thank you very much, Antonello. And on this aspect, on the international view, I would like Stefan, if he's still connected from the first part of the webinar, to complement a bit, because the TwinEU project closely resonates with the commitment of all European DSOs and TSOs to develop a digital twin of the European grid. And your project, the DSO for DT, just started, but I would like to hear your views on how it will complement TwinEU and how the two projects can work together in fostering investment in digitalization of European grids and the uptake of innovative grid technologies.
Yeah, I think, I mean, the TwinEU project, of course, is as in every innovation action, combines the front runners, the early adopters, working on these topics. And I think for DSO Entity, we had some kind of multiplier. We're representing all the DSOs. We have members in all member states. We have a lot of small members also, which usually are not engaging in Horizon projects directly. But of course, now with our project, and it's a dedicated task in our project, we will try to activate also these members or the DSOs, which usually would not engage in such activities proactively by breaking down or shaping the message in a way so that they can comprehend them in an easier way. So I think that's one of the main tasks here, and it's a nice completing the work it's done by the front runners in the TwinEU projects, and we will bring out the message then and help with the uptake throughout the field.
Thank you, Stefan, and definitely from the TwinEU project, we look forward to cooperating and exploring these synergies more. My next question is for Dune. From the first part of the webinar, we have heard from ENTSO-E that one of the biggest challenges, rather than the lack of standards, is the lack of use and adoption of standards. And I would like to hear your view from the Bridge working group. Do you agree on this? And do you have some concrete experiences from the group on what are the greatest benefits that can be brought by the adoption of standards for the uptake of digital twins?
Yes, so absolutely. The use of it's not a lack of standard, it's a lack of use of standard. And this can be facilitated by initiatives such as Bridge that will facilitate the implementation of standards by project, especially I think of Bridge Standard User Group that provides a repository of code components and some webinars to for a project to already have open source basis available to implement the standards and guidance on how to use them. So that can very much facilitate the standards implementation. And of course, the benefit for the project is that once they implement a standard, and if several projects can implement the same standard, then they will be able to communicate together and have this interoperability. It can be at communication protocol levels, but especially the interoperability of data, semantic interoperability is quite important at the moment, and the use of data models and ontologies that are standardized can very much help with that.
Thank you. Thank you very much, Dune. And I think your answer underlines very well what is the importance of data, interoperability of data exchange, and standardization of data management practices. I would like to know from the DECODIT project, so Stratis, what principles are you following as part of your project for the data management aspects? And your solution, as we have seen, is also very focused on its user centricity. So if you could tell us a little bit more about this. And if I'm not mistaken as well, your project is also looking at the alignment with the European Energy Data Space Initiative. So as I asked Antonello, what do you think is the added value that can be brought from that?
Thank you very much for your questions. Definitely aligned with the Common European Energy Data Space, data privacy and data sovereignty, as was mentioned before, also by Professor Monti, are central to our solution. So data spaces will be the foundation for the more or less secure and sovereign data exchange. And the different roles of the users and how they would like to exchange data is the more or less cornerstone of this approach. So I would say definitely an interoperable solution using data space as a foundation, and considering more or less the needs of the different pilots will be the main vehicle for what we are going to achieve.
Thank you very much, Stratis. And last but not least, I have a question for Diego and the DEDALUS project. In your case as well, the dimension that your project is exploring is closer to the user and the household and residential level. And we have heard from the morning that quite a big challenge to the adoption of digital twins is related to user acceptance. And I would like to know concretely what actions your projects carried out to tackle the need of getting user trust and engagement, and also specifically what is the benefit that can be brought in this by using digital twin technologies.
Okay, thank you, Celine, for the question. Basically, at the moment, I want to answer to the last question about the benefits. In this specific stage of the project, we are going to deploy our solution. So we are in a phase in which we have to still collect the feedback. But the social acceptance or acceptance from users is a really relevant point for us. That's the reason why, as you know, social science and humanities is now a very important keyword that is recurrent in many projects. And also in DEDALUS, since the beginning of the project, we arranged several workshops by involving people from the pilots in co-creation and co-design workshops that helped us to understand their needs, but also to propose together potential services based on data, based on the application of AI tools, based on digital twins. So it was a work that we did with the users, completely involved in this process. The idea is, of course, that designing something that comes from their need and is understood from the beginning, we can expect to have at the end of the project a higher level of acceptance from their side. So basically, digital twins are adopted to, let's say, to have a digital copy of buildings, but also a digital representation of end user or occupants' behavior. So that's the reason why we must pay attention to the adoption of digital twins when we involve people in this process. At the moment, we can say that we collected a high level of interest from the especially, for instance, from in the Italian pilot, we didn't expect to find so high level of interest from other people that are sensitive to the effect that energy efficiency or providing flexibility to the network can have. So we were quite surprised about that. So that's the reason why we expect now to get good results from the application of technology that are not only digital twins, there are also other applications, but we expect that also digital twins can provide benefits to the occupants by empowering their capacity to provide a flexibility in the context of demand response programs. So it's something that we'll let's say, announce in the next month by releasing the deliverables that are expected and mainly concern this aspect.
Thank you very much, Diego, and we look forward to hearing about your learnings in later phases of the project, maybe in a next TwInsider session as well. So I pass on the word to Laurent, back to Laurent, as we've already run out of time, and thanks again to all the speakers for this panel discussion as well.
Thank you, Selena, and indeed, thank you very much for all the speakers being with us today, and also, of course, to you, the audience, for joining us. As I mentioned in the beginning, this was only the first edition of a series of webinars or online workshops. In the next phases of the project, we will organize some more sessions on the thematic basis of maybe data exchanges or use cases of digital twins. So this was, let's say, only the initiation of this session. So regarding the materials, of course, we will share with you the video, so you can look back on the main messages, and you can just follow TwinEU to be up to date with the upcoming sessions too. So thank you very much once again, and see you next time. Bye-bye.
Thank you. Bye-bye.
Thank you very much.
Thank you. Bye.
Bye.
Thank you. Bye-bye.
Thank you. Bye.